Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll continue our discussion on gradients. And this time, we'll look at controlling recording on a gradient tape. And we'll look at how we can list variables from a recording tape and how we can selectively watch what items are getting recorded on the gradient tape. So let's get into Colab and start coding. Here I've already imported the two libraries. Now, the very first item that we are going to look at is controlling recording on the gradient tape. And points to note here are that by default, the record all is the option. So if the default is it records everything. And what we need to note here is that the operations from the forward pass. So whatever operations are done, operations from the forward pass are needed for the backward pass. So these are needed for backward pass. And in doing so, what we can do is we can stop recording of unnecessary intermediate operations. So skip unnecessary intermediate operations, and thus we can maybe save on computational resources, or we can expedite the process of calculating the loss in this particular fashion. So the first item we'll look at is we'll create 4 inputs, record them on a gradient tape, and then look at the how we can get the slopes. So the first one is we'll create a trainable variable. Trainable variable, and this is x0 is equal to tf dot variable 5.0 name is equal to x0. And if you remember, the default for a tf dot variable has a setting that trainable is equal to true, and so we do not need to add that in this particular case. The next is we'll create a variable that is not trainable, and we'll call it x1. So tf dot variable, and let's give this a value of 6.0, and we'll name it as x1, and we'll set the trainable is equal to false. Next, we'll look at a variable again with tf dot variable. So if we point to note here is that if we have a variable and if we add it to a tensor, then what we get is a tensor. So we'll create one of those. So x2 is equal to tf dot variable, and let's have value of 7. Name this as x2, and what we'll do is we'll add 1 to this. And point to note here, if you remember from the earlier videos in this series, this particular value of 1.0 is a 0 dimensional or 0 rank tensor. Next, we'll create a tensor. So this is not a variable, it's a tensor. x3 is equal to tf dot constant 8.0 is the value we assign to this, and then we label it as x3. So these are the inputs we have created. Now what we'll do is I will record this. Record record, and for recording then we use the same method with tf dot gradient tape as tape, and here we can write y is equal to x0 2 plus x1 2 plus x2 2 and then x3 2. So those are the operations we are recording on the gradient tape, and note that we have all the inputs x1 x2 x3 that are in here. The thing to remember is that only this one is trainable, others are not trainable. These because these are tensors, and this because we have set it to trainable is equal to false. Now when we calculate the gradient, grad is equal to tape dot gradient, and we calculate the gradient on y with respect to all of this x0 x1 x2 x3, and then we can print this. So x3, and now we can print. So print for g in grad, print in grad, we can do print g, and when we run this, here we can see the output. So the very first one for x0, we do get the output, which is this, and that's the tensor we have rank 0. And for the others, because they are not trainable, gradient tape does not have any values for them, and therefore for the when we use the tape to calculate the gradients, we get a value of none for x1 x2 x3. Now we can also list out the variables that are on the tape. So list variables watched for recording on tape, and to do that we can simply say for var in tape dot watched variables, and here we can use var dot name. So when we run this, I need open close parenthesis here. So here we can see that while the recording was going on in this particular step with tf dot gradient tape, only this particular input was being watched. These were not watched, and therefore when you try to calculate the gradient using that tape, these are not available to calculate the gradient. Only this one is, and therefore we get value only for x1 x0, whereas the rest of the three are none. Additionally, we can manually set controls to what can be watched. So call this watch, and this is user control on gradient tape. So for this, the first example that let's create a couple of cells. We can move this up. Okay. So here what we can do is we can watch or record tensor. Watch or record tensor. So let's create a tensor x is equal to tf dot constant. Let's assign have a value of 5.0, and then we can record. Record is the same step with tf dot gradient tape as tape, and here now what we can do is we can selectively ask TensorFlow to record a particular variable of interest. So here we are recording tape.watch. We are recording the x, which is a tensor, and then we use that to calculate y. So let's call this x square. And now when we calculate the gradients, let's call this grad y to x, and then tape dot gradient y with respect to x, and we can now print, or we can simply say grad y underscore x. And here we see that this particular uh, x, which is a tensor and not a variable, watched because we manually asked TensorFlow to put that on the tape, and so it was then available later on to calculate the gradients. As we can see here, we have a value of 10. Now, similar to watching the tensor, we can also watch or record a variable. So let's see how that can be done. So we can watch or record a variable or variables called x0 is equal to tf dot variable, and let's assign it a value 1.0. x1 is equal to tf dot variable, assign this a value of 5.0. And then with tf dot gradient tape, we can say watch accessed variables is equal to false as tape. And one after we say that, what we are saying is now only the variables that I tell TensorFlow need to be watched. Other variables need not be watched. So despite this being a variable, default it would have watched both, but now it won't, because here we'll specify tape dot watch, and if we ask it to watch x1, it will watch x1. So now if we calculate y0 is equal to x0 square x2, and then if we type y1 is equal to x1 square, so this should be x0, and then we calculate y is equal to y0 plus y1. So now this is where we are recording, so let me type that, record, and here we then calculate the gradient. Grad is equal to tape dot gradient y, and this is x0, x0, x1, x1, and now if we look at grad, we should see the output unexpected keyword argument watch accessed variable, right? There should be s. So as you can see here, now we have x1. Let's print it so it's easy to see. So let's call this this is grad y with respect to x0, and that would be grad of x0, and the next one is with respect to x1. So in that, put a 1 there, 1 here, so we get the output where this is none. So as we can see, we asked the gradient tape to watch only x1 and not x2. So x1 x sorry watched only x1 and not x0. Therefore, when we are trying to calculate the gradients here, the x0 is not available to calculate the gradient, and therefore we get a value of none, whereas we do have x1 that was watched and recorded on the tape, and therefore for x1 we do have the value for the gradient calculated in the output. Now let's look at how we can calculate intermediate results. Intermediate results. How we can get intermediate results. And to get the intermediate results, let's write here, get gradients of the output with respect to intermediate results. So we can pick any step in the neural network, which would be an intermediate step to calculate the gradient. So here, let's create a tensor first. X is equal to tf dot constant, and let's give it a value 5.0. Then we record it. So with tf dot gradient tape as tape, and here we watch x, so we say tape dot watch x, and we calculate y, which is y square, sorry, x square, and then we have z, it is y squared. So as you can see, x is used to calculate y, then y is used to calculate z. So we are it's kind of a chain. And now we can use the tape to compute the gradients of the intermediate step. So, and the gradients that we are trying to calculate is z with respect to y. So we want to calculate the gradients only for this step. Despite the fact that we are watching x, we are not watching y here, but this should get recorded on the tape, and we should have the gradients with respect to y for z. So let's type grad is equal to z with respect to y, and then tape dot gradient and z comma y, and then we can get grad z comma y, and as you can see here, we do get output which is 50. So we were able to calculate the gradients for this intermediate step, which was the last step in this case. Uh, so while we were watching only x, which was the very initial input, the subsequent, so all of this was tracked and recorded on the gradient tape. Now let's look at persistence. So let's create a cell here and call this persistence of gradient tape, and the default in this case to note is that it can be used only once. However, if we set persistent is equal to true, then more than one usage is possible. And to see that in action, let's create a tensor. X is equal to tf dot constant, and this time we'll create a rank 2 tensor, rank 1 tensor, sorry. So we have 1.0 and then we have 2.0 there. Next thing we need to do is record with the same method. By now you probably are familiar with what this line is. Gradient tape, and within this we need to specify persistent is equal to true, and then specify as tape. Now we can say tape dot watch x. We are watching the tensor x that we created above, and we calculate y is equal to x square. So same method that we, same steps that we had up above. So that, and we this time we calculate two gradients. So gradient, so grad z with respect to x, that would be tape dot gradient, and z with respect to x dot numpy. So we immediately convert it to numpy, and then grad z with respect to y, and we say tape dot gradient z with respect to y, then use numpy, and we can print these out. So grad z with respect to x, and then grad underscore z with respect to x, and the same, and so this should be x. Let me copy this and paste it here. So now this is grad a with respect to y. So those are the two options. And now when we run this, we see that we do have output for both. However, if you set this to false, if I set this to false, then we would be able to see the output for this, but we should not be able to see output for this because the gradient tape is already used in this case. When we run this, as you can see, it says non-persistent gradient tape can only be used to compute one set of gradients. So that's the reason, and therefore this thing, we got an error. So if we remove these lines, so if we remove this line and if we remove this line, then it'll work fine, as you can see here. Or alternatively, if we keep this line and remove the bottom line, such as this, again we should see the output as right here. So that's the difference in using true or false for persistence when we are recording on a gradient tape. Next, let's look at uh, how we can use gradients on non-scalar targets, some of which we have already seen, but this is a little different. And before we move forward, a note here that when we are using the gradient tape, so this is just a note, it takes memory to record on a gradient tape. So that's something to remember. And so only relevant items, if we record, then we are not using a lot many computational resources. Let's create another heading here and call this gradients on non-scalar targets. And what we are trying to do here is we are going to create a variable. Let's do that. X is equal to tf dot variable with a capital V 5.0 and just 10. Then we are going to record with the same method tf dot gradient tape persistent is equal to true as tape, and then we'll create two steps. So the first step is y0 is equal to x square, and then we have y1 is equal to 1 by x. Now both of these values are independently calculated directly from x, so y1 does not use y0 in this case. Now if we calculate the gradient, so grad y0 with respect to x, so tape dot gradient y0 with y0 with respect to x, and let's convert it to numpy array. Then grad y1 with respect to x, again tape dot gradient y1 with respect to x dot numpy, and again we can print this out. So print grad y0 with respect to x and grad underscore y0 with respect to x, and then I'm going to simply copy this, paste it here, and change this y0 to y1 as we can see here. And so that's what we have. So when we run this, here we can see that we can work in this way. So we have two steps which are not connected with each other, but the input x is there which is connected, and the gradient tape does watch both these steps, and so in the output we are able to calculate the gradients for both of these with respect to the x that we have. Now a point to note here is that there is alternative way we can calculate these gradients using dictionary format. I just want to show that. We have seen an example of this earlier. This is maybe a repetition of that. Tape dot gradient, and here within open close parenthesis you can specify y0, and so this is y0, and then we have y1, and this is y1, and all of this with respect to x, and we can get the numpy array, and we can create grad. So the difference here is that this time we have two values here on the left hand side, whereas just one value on the right hand side. Previously we used to have just one value here and two values on this side, so that's the difference. Now just a note to mention here is that gradients of multiple targets is the sum of the gradients of each target. Now so far we have seen how we can use different inputs. Here is another example that, well, if we create a variable x is equal to tf dot variable and assign it a value 2.0, we record this and we say tf dot gradient tape as tape with small t, and now we calculate y such that we have the variable x, and then we have this list here with 4.0 and 2.0. Now when we calculate the gradient is equal to tape dot gradient, and this is y with respect to x, and then we get the numpy array of this. We see that the output gradient that we have is 6, and so what that tells us is that if we calculate the gradient, for example, let's say y1 is equal to x multiplied 2.0, and then we have y2 is equal to x and 4.0, and let's comment this out. And here if we then say copy this, I'm going to paste it 2 times and comment this out, and let's call this y1 with respect to x, and let's call this y2 with respect to x, and we have this as y1, this as y2. Now if we print this gradient with print the other one, which is y2, and run this, what we should see, so this should be persistent is equal to true, persistent is equal to true. Now what we should see is that the sum again is 6. That's what the what I was trying to say. If we have, so we have y1 and y2, and so if we look at the sum of this is 6, which is same as what we saw earlier. So that was it for this video. I hope in this video you learned new stuff about how to work with gradient tapes, how to watch elements within that are getting recorded on the tape, and also note that it takes memory to record elements, or it takes memory to record operations on the gradient tape. That was it for this video. I hope to see you all in the next video. Please like, share, and subscribe. Thank you.